Hello, everyone. Thank you all for joining me today. I'm Judy Piper. I'm one of the engineering leads at C Labs and also the host for this Tech Talk series, one of many Celo Foundation's efforts to share and spread Celo technology knowledge with the Celo community. Since April this year, we've been providing this series of educational sessions, starting with the introduction to Celo platform, which I did also, so that anyone can learn the technical ins and outs of a Celo network to support Celo's mission of building an inclusive financial system. For this reason, we strive to make the content accessible and inclusive to anyone who wants to learn about Celo technologies, from mobile applications to distributed systems to blockchain to cryptography to infrastructure. For those who missed the previous sessions, not to worry, we have the recordings available on Celo Foundation's Crowdcast as well as on our YouTube channel. I'll be sending out a follow-up email after this talk. In it, you will find helpful links to learn more about Celo, including today's topic on phone number privacy. Feedback is a gift to us. In the follow-up email, you will also find a link to the feedback survey form. Please don't forget to share your feedback so we can continue to improve the content and keep them relevant to this learning community. And in today's Tech Talk, we invited Rossy from Applications Engineering team at C Labs to share his expertise in building Celo and how the teams at C Labs been working to ensure the end users' phone numbers private and safe. Thanks for joining today, Rossy. Before we start the talk, could you please introduce yourself and share how you joined the C Labs to build Celo?
Of course, yeah. Thanks for that intro, Judy. Hey, folks. I'm calling you all now from Montreal in Canada. But for most of my time working on C Labs, I was actually in Berlin. And that's where Judy and I met. That's where she's calling from today. And I've been working on C Labs to try to build out the Celo platform and make the Celo mission a reality for about 2 years now. When I joined, we were mostly a San Francisco-based company, and that's pretty much where everyone was. And when I joined, I think we only had one person out in Berlin, Marcus, who is our founding director out there. And it's been great to see over the last 2 years, not only have we built out the platform itself, but we've built out the teams. So Berlin is now, a strong office standing on its own 2 feet. I think we have more than 10 people there. Is that right? As well as the Buenos Aires office. But of course, that was before COVID. So now I guess we're an even more distributed team than ever before. And we have people all over the world now who contribute to C Labs, who join our conversations, join the discussions, join the Alliance. It's really amazing to see how things have grown out and spread out. In terms of my specialties, I focus mostly on what we'd consider the applications layer. So if you think of the platform as having 3 key layers, the bottom, which is, of course, the blockchain itself, made up of the blockchain clients all communicating with each other. Then there's the smart contract layer. And then above that, there's all the applications that you can build, any dApp you can imagine. Given that C Labs is or Celo is an EVM compliant chain, so any dApp that will work on Ethereum will also work on Celo. And so, of course, the first application we've built out is our flagship wallet application, which is called Valora, and so happens just launched publicly this week. It's like a super exciting time, and that's the thing that I've probably focused the most on during my time at C Labs. Yep, that's a little intro of me. Thank you for the link, Judy. Yep, valoraapp.com.
Yeah. Do you want to get started?
Yeah, by all means, let's jump on in.
Let's do it. Okay.
Okay, here's my face. All right, our agenda today. We're gonna touch on 4 main topics. And the first one is just a general introduction to Celo's identity protocol. And this is a really interesting topic, one that I've worked a lot on and I'm passionate about, because this is one of the areas that Celo is really differentiated from a lot of other chains in this space. From there, we'll move on to a discussion of some of the challenges around identity privacy. I mean, we want to have an identity protocol, but of course we want to have it in a privacy preserving way. And there are lots of tricky bits that we had to work through to make that possible. And then from there, we'll give kind of a deep dive into exactly how phone number privacy is working on Celo today. And we'll finish off with some future improvements and challenges that we're going to be tackling over the next few months. All right, now this will probably be familiar to most of the folks here, but just to touch on it briefly because it's relevant in understanding why we're doing the work we're doing. Celo's mission is, of course, to build a financial system that creates the conditions of prosperity for everyone, everyone being the really key word in that sentence. And with that in mind, how do we reach the most amount of people possible and get these helpful tools into the hands of everyone around the world? Well, of course, we do that by being a mobile-first digital currency. And when we say that, what we mean is that the protocol has really been designed from the ground up to work well on low-powered mobile devices. Instead of the first users we think of being folks on command line. No, we really think of the end users of Celo to be just ordinary folks on mobile phones, and we're trying to find ways to bring the power of cryptocurrency and all of its utility to people all around the world without needing to understand all the complexities of that. So of course, being mobile first is crucial in that strategy. How does Celo try to serve mobile clients first? Well, we have a bunch of features that we have been implementing over the last, I guess, 2-3 years, really since the beginning. Some of these have been quite tricky, that make us well suited to serving mobile devices. The first is that, of course, Celo has CUSD, which is a stable value currency pegged to the US dollar. So if you think about how a layperson might view cryptocurrency, unstable is kind of a theme that comes up a lot, for understandable reasons. And we think that stable coins are going to have a really important role to play in enabling cryptocurrency to serve people all around the world, over the next 10, 15, 20 years. We think that that's just, we need an ecosystem of coins. It doesn't need to be just one, but having stable value coins is a super key part of how this whole system can work. But then, all right, we have these stable value currencies. People want to be able to actually use them, right? We don't want a network where, like Ethereum, you must hold Ether in order to pay your transaction fees. So another innovation we've added is allowing gas costs to be payable in any Celo currencies. And currently, the only second currency in addition to Celo itself that we support is the US dollar. But we'll be adding additional currencies over time, and any of them will be eligible to pay fees in. This third piece is the mobile identity piece. And I'm just going to gloss over that for a sec because we're going to come back to it. Then just to touch on that fourth bit, fast syncing. This is one that I'm particularly excited about. At the moment, Celo's sync times are about 20,000 times, and that's not an exaggeration, faster than syncing a new client with Ethereum today. And that's because we have built our own ultra-light syncing protocol to make the sync experience just so much lighter, so much faster. Essentially, it's infeasible to sync an Ethereum to the Ethereum chain on a mobile device, but it is totally feasible to do it for Celo. And we're not stopping there. We're actually exploring other ways to make it even lighter, but that's a topic for another talk, so we'll leave it at that. And going back to mobile identity, this is really what we're going to be focusing on today in this talk. How does identity work on Celo? And by identity, we really mean how do people find each other on the Celo network so they can interact with each other. A quick 10,000-foot view of the whole identity protocol. We've really thought deeply about identity, and it's not just something that's sort of been, slapped on top at the last second. Celo has identity features baked deeply into the platform, so all validators are themselves running key pieces of how the identity protocol works. So in addition to supporting consensus, validators of Celo also support the identity protocol. And the end goal is ultimately just to help people find each other, right? That's really what it's all about. That's what identity is for. I guess I'm going in circles. Sorry. But anyway, the system of identity is really built on two key pillars, and one is attestations, one is mappings. By attestations, what we mean is when you claim to have an identity, are there attestations that prove it? Can you prove you control this identity, whether it be a phone number or whatever that you claim to have? And then the mapping, whatever piece of identity, in this case, let's talk about phone numbers, that you claim to have, we need to map that to something that can be used on the network, practically speaking. And that means addresses, the same addresses that folks will be familiar with from Ethereum, Bitcoin, whatever. All networks have addresses, and Celo's no different in that sense. So one of the key features that we're really going to be diving into today is that mapping, in particular, phone number to address mappings. So that's currently the type of mapping that we support, but we'll be adding more types coming soon. Like you could imagine email to address mappings or username to address mappings. We decided to start with phone numbers because particularly in emerging markets, everyone has a phone number. And that's sort of, despite it being an old and somewhat, janky system, it is a very universal system. And it's one that people have invested a lot of effort into curating their list of contacts and phone numbers. So yeah, that was one of the things that Celo built early on, was this ability to interact with people using phone numbers. And to make that possible, we have underlying this phone number to address mapping on the chain. All right, the attestation flow. How does someone prove they control the phone number that they claim to? So if folks have used the Valora wallet before, you'll know that in one of the early screens, you're asked to input your phone number, and that's so that other people can find you using that phone number. But of course, we can't just allow anyone to claim any phone number, or someone might try to claim 1 million of them, or maybe just try to claim one high value one, like, oh, I happen to know what Jeff Bezos' phone number is. So I don't know how I would know that, but let's say I'd want to claim that. Now, of course, we want to make sure the system is honest. And to do that, there's a whole attestation system that's been built in order to verify whether or not a phone number is actually controlled by the user when they claim. So what you're looking at on the right side here is essentially a flow chart. And I don't know if folks can see my mouse. It would be helpful to sort of draw attention to these different points as we go. But starting in the middle, looking at the wallet with the two circles, green and gold. From there, the first thing that the wallet is going to do, or any client's going to do when trying to get an attestation for a phone number, is they're going to request it. And this piece actually costs money today, but we're exploring ways to make it free. So you're going to pay a small fee and do a transaction, and that's going to go to the attestation smart contract. And once that goes through, you are now entitled to an attestation. You've just bought yourself an attestation. And with that attestation comes a randomly selected validator. So at any given point, the Celo network has about 100 validators running, or exactly 100. And of those 100, one will be randomly chosen. And that random bit is actually super important because we want to make sure that even if you wanted to, you couldn't collude with particular validators in order to falsify this whole attestation flow. So going back to the wallet, what you now have is this attestation request and an associated validator. So you now need to communicate with this validator and say, hey, I was assigned you, and I'm trying to prove ownership of this phone number. So we do what's called the reveal step, and that's heading to the bottom right now. We're down at number 3, reveal phone number to issuer. Issuer in this case is the validator. How this works is you essentially off-chain post a request to the validator's attestation service and say, hey, I have this request that I've bought from the smart contract, and I have this phone number, and I'd like you to send me a secret attestation code to this phone number so that I can prove that I received it. And by proving that I received it, I'm proving I control this number. But just to be sure that you couldn't collude with a single validator, you actually do this whole process 3 times, and it happens in parallel, so it doesn't feel too long. But this happens 3 times for 3 different validators, and you get 3 different codes. And all those codes get inputted into the wallet, which then get written back to the smart contract, and that's this loop over the top, step 5 that you're seeing here. So yeah, once that's done, you've completed the loop, you received the code, proved that you received it, and wrote it on chain, and you now have 3 or more, because you can get as many attestations as you want. You have 3 or more attestations proving that you control the phone number you do, and you're now what we call verified. So once you're verified, anyone on the network is going to be able to look up your phone number and send money to you that way, or request from you that way. Just in general, they'll be able to interact with you on the Celo network just using your phone number. Cool, we're done. That was it. We wanted to support phone numbers, and we did. So thanks everybody for coming. But not actually, of course, it's never that simple, right? All right, you've just written your phone number to the blockchain, which is amazing, right? You've been able to prove your control of a phone number and do this in a decentralized way. But the obvious problem is that, hey, I've just written my phone number to the blockchain. And that means it's like all blockchains, everything is completely public and permanent. And that's undesirable, right? We don't want to force people to have to publish their phone numbers in plain text onto the chain. So this is privacy issue number 1, that the numbers would be public, and that once you establish this mapping, anyone would be able to look up your number. And not only that, but because the mapping of phone number to address would be public, people could also say, starting with your phone number, check your balance, which is maybe not ideal. Maybe you don't want everyone to know how much money you have. So the solution would be, of course, to hash the phone number, right? Very easy to go from phone number to hashed phone number. Very hard to go the other way. So if we just write a hash of the phone number to the chain, then now we wouldn't have to worry about phone numbers being there in plain text. But no, that's not quite it either. That's a great improvement, but it's not enough on its own, it turns out, because phone numbers might seem like there's a whole lot of them, but actually the domain space of valid phone numbers is relatively small, and hashing power can be very, very large. So it would be pretty easy for an attacker to just hash the entire set of valid phone numbers, or maybe they don't even need to do that, right? They can just hash the set of phone numbers in one particular area code, like maybe Beverly Hills, where there's a lot of rich people, and so I'm just gonna try and harvest all the numbers in a particular area code. So that would be too easy. And in fact, they wouldn't even necessarily need to do that, because it's kind of well known that there are rainbow tables of pre-hashed phone numbers for all popular hashing algorithms sort of floating around the dark web. So how do we prevent people from easily just computing or purchasing a rainbow table of all the hashes of phone numbers? And the next solution is to add some kind of a unique salt or pepper in with the hash, right? Now, if we had a unique salt or pepper, you would have to essentially, it basically becomes totally infeasible to compute a rainbow table, because any phone number can be combined with any random number, anything, and you get total garbage out. So it's infeasible to have to actually pre-compute the whole set. But then we hit problem number 3. And that's, okay, great. So we can add this secret salt, the secret salt or a secret pepper in with the hashing, but how is anyone else on the network going to know that secret in order to look me up, right? If you keep in mind, we can have perfect security, but then we would sacrifice all utility. Like, we need to make sure that at every point, people can always look up the people in their contact lists and find people on the network that way. That's the ultimate goal. So how do we make sure that peppers just being a secret salt, how do we make sure that peppers are secure but also accessible to all the people that they need to be? And folks that have lived in Berlin, like myself, might recognize this building to the right here. This is Berghain, just a fun little call out. People might know it as a mega club that has like a famously, or I should say infamously, difficult and like restrictive access policy. So I felt like that was a good call out on the topic of accessibility. So anyway, if everyone can access all phone number peppers, then the mapping isn't private. So that's really problem number 3. We want to make sure that these peppers can be accessible to anybody, but only in limited amounts, right? We can't have a malicious actor just going and retrieving all the peppers. Otherwise, there is really no point to having them in the first place. So solution number 3 here is a rate-limited API that will control access to the peppers. All right, quick summary, because we just covered a couple things here. What we have at the offset is a hash of the number leading to an address. That's like what the phone number mapping could be in a naive solution. But what we want to achieve is a hash of number plus pepper to the address. And we want to do that in a way that whenever honest entities need access to the peppers, that they can get it.
Where the pepper coming from?
That's a great question, Judy.
Oh, no, it's not my question. Deepak asked.
Okay. All right. Well,
but I think it's relevant that we just quickly
yeah,
go
like
over.
That's perfect. I could not have queued up a more perfect segue. Where does the pepper come from? To make this possible, a new service was created, and that's ODIS. ODIS stands for the Oblivious Decentralized Identifier Service. In short, the peppers come from ODIS. ODIS serves peppers to clients, and currently the only client that would use it day to day is the Valora wallet, but this is an open system and just a built-in part of the Celo platform. So all competing wallets or CLI clients or whatever, if anything that wants to build on Celo can query ODIS whenever they need. And ODIS keeps a quota record for all accounts that query it. And that's what essentially enforces the rate limiting. That's how we make sure that honest users with ordinary accounts that query, a few contacts day to day can always get the peppers that they need, but someone that was just spamming the system trying to get all of the peppers would not be able to. All right, why is ODIS called ODIS? Let's just dive into these terms a little bit because it actually helps explain how the system is working. We call it oblivious because one really nice feature of this system that has been built is that even ODIS is unaware of the phone numbers it's operating on. So if we think back to the privacy attributes that we were trying to achieve here, we wanted to make sure that we could keep phone numbers safe. And we realized it would be possible to keep phone numbers safe even from C-Labs itself, which is one of the runners of this service. So ODIS handles phone numbers in a blinded way, serves peppers for them, and all the meanwhile never even knew the phone number that it was handling. It's decentralized because there are many parties. So C-Labs is not the only entity running one of the nodes that consists of ODIS. In fact, there's many parties, and no individual party can access the secrets. In this case, the secrets is the peppers, or what's needed to generate the peppers. It's the identifier service because most of the utilities that it's currently doing are around ID generation or matching. So, of course, in the generation of peppers, it's necessary for the identity protocol. But there's actually a second thing that ODIS does, which is matchmaking. So if you have two users that mutually have themselves in their contact list, then we can securely notify them that, they mutually know each other. And then, hey, look, 10 people on the Celo network already. And it's a service because it runs off-chain and it's available to everyone to query. So permit me now a brief digression. This is going to seem a little off course, but I do have a point, I promise. I just wanted to call out this scene from the first Star Wars movie, A New Hope. If any other nerds out there will maybe recognize it as the moment where they're dissecting the Death Star plans. And there's this quote: "An analysis of the plans provided by Princess Leia has demonstrated a weakness in the battle station." So, wow, how convenient, right? How convenient that this super secret, ultimate super weapon that the Empire has been working on forever has not only has a vulnerability but that the rebels have been able to acquire the plans for this. So that's kind of, one of the long-standing plot holes in the original trilogy. It's like, okay, that's great and all, but how did Leia get the plans? Surely the Empire would have tried so hard to keep this stuff locked down, right? So plot hole, where did Leia get the plans? Now fast forward a good 39 years and Rogue One is released. And Rogue One, for folks who haven't seen it, it's a pretty good movie actually, and it tells the story of how the rebels got the Death Star plans, right? It's this huge project, like most big Disney movies these days, right? Over $250 million budget, tons of, hundreds or thousands of people working on this huge project, all to essentially, from a narrative perspective, fill this like small plot hole in the first movie of like, okay, but where did they get the plans? What's my point? Back to reality, ODIS was a joint effort across the crypto and protocol and applications teams. And it actually involves a lot of different technology. It uses Rust, it uses Node, TypeScript, WASM, Docker, Azure, and some custom-made BLS, threshold BLS signatures and the related cryptography for that to make this possible and to make the Pepper generation possible in a way that ODIS itself doesn't even know the phone numbers. It relies on a bunch of different parties to work. And the whole thing was done also that we could fill this small hole, you might call it a plot hole, in this simple hashing algorithm of hash number plus something is address. So in
next
other
Celo
words,
Tech Talk is about the Star Wars, the next generation, right?
In a way.
Yeah.
So my point of this whole digression, kind of just for fun, was that you can think of ODIS as the Rogue One of the Celo platform. All right, so let's dive in a little bit deeper into exactly how ODIS is working. Here's an architecture view. The system is currently comprised of one combiner and multiple signers. Kind of like the name implies, the combiner's job is mostly just coordination and combining. And that's actually the thing that clients are hitting with their requests. So if we think about the basic flow, Valora will send a request to the combiner. That's totally public and anyone can query it. And the combiner will then coordinate with the N signers. In this case, N is 9. ODIS has 9 different signers from different parties. And once all of those signers have serviced the request, in this case, that means doing a partial signature of it, those partial signatures will be returned to the combiner, which will combine them into a single full BLS signature. And that's actually what gets returned to the client. A few other callouts, you'll see some SQL databases, and that's just like a little bit of state gets maintained in order to enforce the quotas. It's basically a history of, all right, what accounts have queried when, and what is their current quota. There's a connection down here with the signers. You'll see the green box of to Celo, and by that we mean the Celo blockchain. And that's relevant because in order to know how much quota someone should be allocated, their transaction history is actually looked at. So the more transactions that you do, the more quota you're entitled to. But to know that, we have to take a look at the blockchain. And then finally, down and bottom right, a very important piece is, of course, the key store. So this whole system is based on distributed keys, and each signer having one partial piece of the larger key that signatures get combined into. So those keys all get stored in a secure key store. Every signer can choose sort of where they want to keep it, but mostly it's in various cloud-based key stores like AWS, Azure, and Google Cloud. Okay, now this looks a little intimidating at first, but we're going to break it down. What you're looking at here is the full request flow for ODIS, starting from a client like the wallet all the way through the combiner and into the signers. Let's break this down a little bit and just look at like the key sections of it in pieces. The first section is that top left, and this is part 1 of 3, request message blinding. Before you query ODIS, in order to make sure that ODIS can actually see the phone number it's interacting on, the client will blind the phone number. And this is done with a call into the BLS library that we've written specifically for ODIS and for this use case. You call in, you essentially give it a random seed. Say, here's my random seed. Give me back a random, give me back a blinded phone number. And to put it a simpler way, you can think of a blinded phone number as like an obfuscated phone number. It essentially just looks like ciphertext garbage. And once you've got that blinded phone number, that's what you hand off to the combiner. So that's part 2, partial signature collection. In this part, the combiner is doing individual requests to all of the signers. And we do this for a bunch of different reasons. One of them is that, one may ask, why do we even need a combiner? Couldn't the client do this? The client could do this themselves, but actually on poor internet connections, which many people in our target markets may have, having to coordinate 9 or more separate network requests to a geographically distributed set of signers could just be really slow and pretty unreliable. So instead, we just do one single request to the combiner, and it does all the orchestration needed. It also keeps things simple on the client side, which is nice. All right, the request, what the combiner was given was a blinded phone number, and that blinded phone number is going to in turn be handed off to all the signers to partially sign. And that's what you're seeing in this top part of the flow diagram here. Partial sign request, partial signature comes back. And this happens up to 9 times, though it actually doesn't have to happen all 9 times. And to understand that, we need to understand the concept of threshold signatures and kind of a K of M system. The way this works is that you don't need all of the partial signatures in order to combine them into a valid full signature. You only need some threshold amount. And in our case, just like the consensus algorithm of the blockchain itself, went with 2/3 as the threshold. So when the combiner is querying these different signers, it only needs to get a valid response from up to 2/3. Though generally speaking, it does get all responses. And this is nice because if we're having downtime with one of the signers, or if one signer is going rogue for some reason and is trying to act maliciously, the system can tolerate that. It also means that no one signer can, on their own, get the secret peppers. You need at least 6 of the 9. Once the combiner has at least 6, it's going to combine them into one signature, and that's what it's going to return to the client. And if you're curious about the, I'll say, crypto magic that actually makes all this possible, this is all open source, and you can go to the Celo Threshold BLS repo linked to here for all the details. Now the client, in this case the wallet, has just been given the full signature. But that signature was on a blinded phone number, if you'll remember. So the first thing it needs to do with this signature is it needs to unblind it. And this part is actually remarkably cool in the way it works. Simple to explain, but complex in its underlying workings. Essentially, the unblinding process is ripping out the random seed that was added at the beginning when you blinded the phone number. So it's like this transformation you did in both directions. First, you blinded it, and then you unblinded it, and what you're left with is just the pure signature instead of the random data on which it was performed. And with that signature, you of course need to verify it, because as a client, you can't take for granted that ODIS is behaving properly, or that you're actually communicating with ODIS in the way you think you are. So you take that signature and you verify it against the publicly known public key for the whole ODIS system, and clients can just hard code this in. Once you've verified it, you say, okay, I now know I have a verified signature from ODIS, and the last step is just to hash it. And that's actually where the pepper comes from. We sort of like to say, for the sake of simplicity, that ODIS gives the peppers, but if we're being pedantic, actually ODIS gives signatures, which you hash to get the pepper in a deterministic way. So for the same phone number, you will always get the same pepper. And that's why when I verify my phone number, and then when you look up my phone number, we always get the same pepper, and we can find each other this way. A quick word about our ODIS partners. We're currently running 9 trusted partners, though we intend to expand that even further. The system, like most decentralized systems, will benefit from having even more trusted parties, making it even harder for any kind of collusion. The current set, we can't call out the partners just yet, but we'll be officially announcing that set soon. But I can say that the current set includes a few of the Celo validators, a few very large tech companies that you have undoubtedly heard of, and a few very well-reputed universities that you've also undoubtedly heard of. And yeah, like I said, we'll make the official announcement soon. There's just still a bit of paperwork to handle. All right, that was our deep dive into exactly how ODIS is working. But that's only what we built so far, and there's actually a lot of really cool things that we can expand the system into. So I just want to call out 2 of them in particular, and one of them is blinded matchmaking. Right now, I mentioned that ODIS can do matchmaking, but that matchmaking isn't quite as privacy preserving as the pepper generation process. It does only handle hashed phone numbers, but suffice to say, we can't make the 100% guarantee that even C Labs can't, if we really try to deobfuscate matchmaking. So that's like the natural next step. Of course, we'll implement blinded matchmaking as well, and then that will allow us to make the same security guarantees about matchmaking between users as we can about pepper generation for phone numbers. And then as an additional bonus of what we would get once we implement this next step is we can also inform ODIS queriers of the peppers for any phone numbers that get matchmaked. So right now, all we can do is inform you, hey, you know, or you have in your contact list these 10 people on the Celo network. But wouldn't it be great if we could say, you know these 10 people, and here are their peppers, so you don't even need to use your ODIS quota to find out their peppers. That way, right off the bat, the typical user will need to do many fewer ODIS queries and use much less of their quota, just because the people that they're likely to interact with anyway, people in their contact list, they already have the secret peppers for them. The next one is I'd say kind of a big bucket that affects things all across the Celo identity protocol. And the goal is Feeless Onboarding. At the moment, to get verified, you have to pay the verification fee, which I believe is 5 cents per attestation. So to get the 3 that you need to pay 15 cents or more. And while it's very useful as a Sybil resistance prevention mechanism, just to make sure that it's prohibitively expensive to attack verification on the network. It's also unfortunate that it doesn't quite meet users' expectations, right? People are pretty used to installing apps and just having a free, seamless onboarding experience. So it would be really, really beneficial if we could offer a path for Celo users, in particular Valora users at first, to onboard and get verified all without any money in their account. Right now, you need the money not just for verification, but of course for doing the ODIS query as well. So this is a tough problem that touches on a lot of things, and I'll resist the temptation to go down this rabbit hole. But yeah, this is one that we're actively exploring right now, this milestone, and we'll be kind of building out solutions for over the next couple months. And if this interests you, I could recommend that you go to Discord and engage with the conversations there. Okay, we just covered a lot of content. Let's do a quick summary of everything that we went through. The first is that Celo enables the optional use of phone numbers as IDs. I didn't mention that before, but of course, this whole system is optional. If you prefer addresses, that's totally fine. ODIS keeps phone numbers private on-chain in order to make sure that what gets written on-chain is a heavily obfuscated version of your phone number. ODIS plays a key role in that whole system. No one, including C Labs, can reverse the mapping. So no one can look at the data on-chain and see the obfuscated identifiers that addresses are mapped to and reverse it the other way. So I could never say, I have this address and I want to know what phone number it's for. I could only say, I know this phone number. I want to find out if there's an address mapped to it. There are even more privacy-preserving improvements in progress. I just mentioned a few, but there's actually a whole bunch of things coming down the pipeline. And finally, Star Wars Rogue One was actually surprisingly good. I mean, you expect spin-offs to kind of be sloppy money grabs, but solid story structure, decent character development. It wasn't bad, really. And if you want more information, we can refer you to docs.celo.org, which is an ever-improving source of documentation for the Celo network. A quick call out to next week's talk. Kevin Jua is going to be doing a deep dive into the Celo blockchain internals.
Well, thanks for doing my job.
Oh, sorry.
No problem. I guess I should watch the Rogue One movie again. Ask a question. We have a couple of new questions came in. So how do we make sure the combiner is resilient to denial of service attacks? That's
a great question. At the moment, it is a single point of failure. It runs as a cloud function, so it will auto scale as necessary, but it's still conceivable that it be subject to a DOS attack. I think it's totally natural and worthwhile to basically make that the next point of decentralization. And it would be totally feasible to run several combiners, geographically distributed so that no one could take down the ODIS system.
The question from Jake, once I transact with someone, could I observe their balances and transactions after on a block explorer?
Yes, good question. Once you know the address, then things are open, like most blockchains. So you can always look up the different things that an address has done, including their token balance and their transaction history. And there's things we can do about that, and we are exploring medium to long-term solutions for transaction privacy. But that's a whole subject for another talk.
Cool. One more question from Mark. Can you give an example on how Feeless registration could work?
Yeah, don't hold us to this, because at the time of recording, this is just sort of one of the solutions that we're exploring. But you could have something, you can imagine like the Celo equivalent of a gas station, where we have what we might call the onboarding service, where we would allow, in certain cases, Valora users to do transactions via the onboarding service. So a key concept here is one of meta transactions, in which one might have signed transactions for themselves, but have the transactions sent and paid for by something else. So you could imagine a system where I would sign the transaction to request the verification, but then I would actually hand that off to, say, an onboarding service to send and pay for me. Yeah, and of course, there's pros and cons of a system like this. It has limitations, but that's one option that we're considering.
Cool. Any other questions from the audience? Going once, twice, 3 times. All right. Thanks, everyone. What? One sec. Can you share a little bit more about how the quota works?
Yeah, definitely. The quota has 3 key factors right now to determine what you're entitled to ask for. The first is a minimum balance. And this is probably pretty self-explanatory, but like we can't just have empty accounts querying, or one could just make infinitely many empty accounts and query that way. So you need a min balance. You need we look at your transaction history. You could imagine that over time, one would sort of be looking up more and more phone numbers. And we want this to behave in a way that is kind of like you maintain a steady quota. So roughly for every 1 or 2 you look up and then transact with, you're entitled to another one. Suffice to say,
so it's more like a rate limited based on proportion to the balance that you have?
It's rate limited based on how many transactions you sent. And that's nice because transactions cost money. And that means to send transactions means you spent more money. The more money you're spending on the network, the more legitimate you look. And it also just puts this obvious barrier that you couldn't look up unlimited numbers without spending money for transactions for all those lookups. And that will make it prohibitively expensive to really harvest large amounts. And then the third factor is just your verification status. Once you get verified, you get just a one-time bonus, which I believe now is something like 30. So it's like, hey, you went through the trouble of getting verified. You can look up to 30 right now without having to even do any more transactions.
We got another great question. How would this mobile security work for users who don't have smartphones?
Yeah, I mean, that's a rich area of discussion that we haven't really started tackling yet. Serving users without without smartphones and without access to a desktop is a gap currently in the people that we can reach with Celo. But it's an important gap, and I know there's some grant projects out that are starting to look at this, and I think we'll also at C Labs try to put some attention on that too when we can.
Awesome. Thank you everyone for joining, and especially thanks Rossy for joining, giving this talk.
Yeah.
Okay.
Thanks everyone.
Yeah. Thanks everyone. Cheers.